I'm going to go ahead and open things up here so folks can start joining.
Okay, so I would just say a little bit introductory words, just a minute or so.
Yep, no worries. All right, so looks like we have 10 folks joined us here so far.
So it's still 1 minute to go, so
All right, so looks like it's 10:01 here. Can everybody hear me okay? Welcome. I am Mark Richardson. I am a technical project manager for the Chameleon Cloud platform, and I'm currently supporting Mark Powers, who I'm joined here with today, who is also a research software engineer. I will let Mark introduce himself as well. But we're really excited to be here today to talk to you about Chameleon. So let me hand it over to Joseph to give a little bit of introductory remarks, and then we can get started with the presentation.
okay, thanks, Mark. So thanks a lot for joining the SC25 Author Chameleon Cloud webinar. My name is Josef Weidendorfer, and I'm the reproducibility chair of SC25. And we also have here Jennifer Green, which is the vice reproducibility chair. So you can ask us questions at the end of this webinar. As I mentioned in the invitation mail, you may either already have prepared the artifact evaluation on Chameleon Cloud, and then this is a chance to get the latest tips and strengthen your AI artifact evaluation, or you may have decided that it's too tricky for us to reproduce on your exact large supercomputer because you may not be able to provide access and budget so easily. So in this case, the Chameleon Cloud allows for a shrink down version, where we still can give you then the functional evaluated batch. And just as a reminder, so the submission deadline is next Monday. And when we started to think about, discuss about what could we provide from for you for using the Chameleon Cloud for the supercomputing conference, there was a proposal, the suggestion actually from the persons who funded, manage, and run the Chameleon Cloud to provide a webinar. So we do this here today, and I just want to thank shortly Kate Cahy. He actually, I think, funded the Chameleon Cloud effort, which is actually funded by NSF. Thanks also to Mark Richardson and Mark Powers, who run the webinar today. And as announced, you get a deep dive into what Chameleon Cloud can provide, how to use it. And we also want to add a section on tips, how to strengthen your artifact evaluation. And as I mentioned before, we end with a FAQ about any open questions you have. And with that, I want to hand over to Mark.
Thank you so much. So yeah, we're excited to be here today. Kate Cahy, who is the the lead PI for Chameleon, she would love to have been here today, but unfortunately has some other priorities. But we're excited to show you around the testbed, show you what can be done with Chameleon, and specifically how you can use it during this period while you're creating your artifacts and submitting them for evaluation. So as I mentioned, my name is Mark Richardson. I'm joined by Mark Powers, who will probably be talking a little bit more later in the meeting. And then you can see our emails on the slide here below. So if you have any questions after this, feel free to reach out to us. We also have a help desk and a forum, as well as other ways to get in touch. So I'll go through some of that more a little bit later in the talk. And I just realized I wasn't sharing my screen. All right, so hence why I was talking about emails. They're on the screen now. So you can jot those down. Maybe Mark will pop them in the chat as well, but don't worry about it. We got plenty of ways to get in touch. All right, so I just want to start off with kind of a brief overview of Chameleon. And one thing here that I want to emphasize off the bat is something that makes Chameleon unique to this whole testbed space. You know, there's a lot of testbeds out there. A lot of them are open source, offer compute and other capabilities to researchers such as yourself. Chameleon, what we really think sets us apart is the fact that we focus on this bare metal reconfigurability. And you know, we really give our users full capability on the system to do anything that they might, you know, comes to mind. Obviously, if you're going to do something that looks suspicious, we might ask you to tell us in advance. But for the most part, you know, we know that researchers want to kind of break things and do things that you're typically not supposed to do. So we try to support that as much as possible. And that's really where that configurability aspect comes in. So that's a big key of what we do for the testbed. Of course, this comes with huge diversity in scale and hardware. As I'll go through a little bit more on the next slide, we have two main sites, recently added a third site at NCAR, which is still growing. And these all have various CPUs, GPUs, storage, networking hardware. All of this is open to users, and they can reserve it and use it. One thing to note is Chameleon is an open source platform. We all are built on top of OpenStack. So a lot of the stuff that you're going to see today is going to be extensions of OpenStack. However, we've kind of added in a lot of custom features specifically to support research in computer science. So we'll be going through some of that as well. but it's just good to keep in mind that a lot of this stuff is based on OpenStack. So if you're familiar with OpenStack, you're probably, well, it says right here on the slide, you're 50% of the way there. And then a big part of what we do and why we're here today is digital artifact sharing. So we're going to talk, of course, about Jupyter and Trovy and some of the other features that are available through those services that will allow you to hopefully make it easier for you and your evaluators, your reviewers, to look at your artifacts and assess them. Just a quick overview by the numbers. So Chameleon's been around for about 10 years now. In that span of 10 years, we've had over 12,000 users on the platform. We've all working on about 1,200 or so unique projects, and this has resulted in over 800 papers published. Chameleon hardware. So as I promised, I get into the hardware a little bit more. This is, gonna pall in comparison to actually going to Chameleon yourself and checking out the hardware that we have. We have a great hardware catalog that I'll mention and show you a little bit later. But we are just to give you a taste of what we have in terms of hardware. So as I mentioned, there are two primary sites. These were the original sites, Chiat UC and Chiat TAC. Chiat TAC is slightly larger. It does have more nodes in general, although Chiat UC tends to have more of the kind of updated cutting edge hardware. So you can see we have like A100s at GPUs. We also recently added some H100s to a different site. So there's actually a KVM site where you can launch virtual instances, and that is also available. So we have some pretty cutting edge hardware available on the platform. As I mentioned, CPUs, GPUs. There is an FPGA. There's two FPGAs, I believe, available, and then some storage, networking, and then TAC has a lot of the same, just a little bit more older nodes and a lot more. Oh, there's H100s, a little bit more scale. So if you're looking for more kind of scale rather than cutting edge, TAC is probably a better place to go. What does the typical experiment workflow look like on Chameleon? So all of this is kind of embodied in the idea of creating an experiment environment. So we kind of look at that at three different phases. We have kind of the discovery phase where you're looking for your resources, you're trying to verify which ones you're going to need for your experiment. Then you're going to allocate these resources. So on Chameleon, because we're working with bare metal, we're only giving access to one node per user rather than, say, a virtual environment where you'd be slicing up your resources. So because of that, there's a much greater need to plan in advance and kind of be aware of these tensions that can arise. So we do use advanced reservations on Chameleon. These can be made through the testbed itself, which we'll go through. And then finally, we have configuring your environment. So this would be once you've allocated your resources, you then select your image or your templates or whatever you're going to use and start building on top of that instance. And this is where, a lot more of the sophistication comes in. You have your orchestration things. This is all going to depend, of course, on what you're hoping to do and what you're aiming to study. So that's just a brief overview of the workflow. I should mention too, we do have edge hardware as well. So if you're doing anything that involves some kind of edge piece, there is Chiat Edge is a service that we provide in addition to these other sites. Chiat Edge is going to be container based. So all of this is going to be done through container deployment. We do offer some additional capabilities, such as the ability to add standard IoT peripherals as well as bringing your own device. So if you have hardware and you want to add it to the ChiaEdge fleet and then use it through ChiaEdge, we provide ways to do that. And again, I'm going to go through more of this in detail. I'm right now kind of just giving an overview. So we have a variety of images, of course, on the platform. I think right now we currently support 8 images, and then we have 2 heat templates for more complex appliances. These are images that we ourselves keep up to date and make sure that they are working and as expected. And if you have issues with these images, you can reach out to us about them specifically and ask, what's going on? Why isn't this working? And then the other cool thing is that we also have a lot of user-supported stuff uploaded on Chameleon. So there's a lot of appliances that are user-uploaded, and these are all taken by the users from the environments that they've built on the system. So in a lot of cases, it could be a good idea to kind of browse through these. In some cases, you might find something that isn't necessarily exactly what you're looking for, but maybe is something similar that shares a lot of foundation for the environment you want to build. And then you can kind of get a little bit of a head start there. And then, of course, you can use this aspect, sharing your images back with the community, as another way of documenting your work and sharing artifacts of your experiments. So as I mentioned, snapshotting, making your own image. So we provide a built-in utility for Chameleon called the snapshot, CC snapshot tool. And this is basically a way for you to kind of take that image as you have it in that moment and save it, and then come back to it at a later time or share it with other people to continue building. So, we're starting to get into more of this kind of packaging experimental environments. We have, as I mentioned, kind of 2 different methods of doing this on the test bed. One is the kind of declarative method using heat or orchestration tools. So we do provide those kinds of support for those kinds of features. And then we also do have imperative methods. So this is going to be more on the CLI or Python Shi side of things. Python Shi is a Python library that includes a lot of utilities that you can use to make reservations on the test bed, basically do everything that you would do through the graphical user interface. And these can be integrated into Jupyter environments. So you can make these nice notebooks that have a mix of text and code and pictures all in one place. And you can send your reviewers to these artifacts, and they can hopefully just run through each of your codes and replicate your result. Now, that's obviously one particular method you might use. That's not going to necessarily work for everyone, but we'll get into more of how those actually look. So again, orchestration is going to be a big focus of what we're looking at today. So Heat and Terraform are both experimental configurations that we support. And then we also have, as I mentioned, there's a lot of user contributed stuff. There's a lot of staff contributed stuff to take advantage of on the hardware, on the test bed. So this is a good example of MPI cluster template. This is available on the Trovy dashboard, which we'll go through a little bit later. And this is something that you could potentially utilize for your own experiments and build on top of. And then networking, just a few notes here. So we do have floating IPs, which are good for SSH access, sending, receiving files, etc. We have routers, shared networks as well. If you need extra interfaces or isolated networks, we do have ways of getting those resources and bring them together with other resources. And then we are also integrated into some of the Fabric network. So there's some interesting things you can do cross sites using the Fabric network as well. Finally, I want to go a little bit deeper into the practical reproducibility aspect of what we're talking about today. So practical reproducibility is what we kind of are guiding our shining light on the hill, so to speak, for Chameleon when we think about how to facilitate reproducibility specifically in computer science. And the question that Kate asked about, I don't know, 3 or 4 years ago was, is it possible for digital experiments to be as shareable as papers are today? So I won't get into too much of the philosophy of this, but I just want to mention this as kind of a backdrop for a lot of the methods and tools that we're talking about today. The other thing I want to point out early on too is that we do have a recent workshop report that we published in April of this year. This was the culmination of a community workshop on practical reproducibility and systems and HPC computer science. So we held this in Atlanta. It was co-located with Supercomputing 24, and we were invited a lot of authors, reviewers, chairs of artifact evaluations from past to basically talk about what is challenging and what kinds of recommendations, things we can do to make practical reproducibility more of a reality. So the QR code is on the screen here. I highly recommend checking it out if you have some time. It's got a lot of interesting insights in there, a lot of complaints from reviewers about what they hate when they're reviewing artifacts. So I think it's a good thing to look at and just get a sense of, okay, this is what the people on the other side are dealing with. A couple of kind of high level insights that we got from these from this community workshop. And, you know, a lot of these are going to be somewhat obvious. But, you know, what we were trying to do is kind of lay out kind of practical checklists. And so there's actually checklists appended to the end of the report that you can look at. But, you know, we tried to split it into kind of 2 different areas of insight, one being kind of the experiment packaging side. So looking, you know, comprehensive packaging. Do you have hardware? Do you have your software? Is data important to your experiment? Do you need to, you know, include some aspect of are they getting the right data? Longevity was an interesting discussion point that we talked about a lot. You know, but again, a lot of these things decay. So how can you perhaps tweak your artifacts to allow them to be more long running? You know, shifting focus more from can it run once to can others run it? Are there, you know, viable scales for large experiments that require huge clusters? Is there some way to scale those down? And we're really trying to kind of get at this car without a road challenge, right? So we have the cars, we have all the great computers and all that stuff, but how do we get it into a shape where we can actually share these experiments and they can be as easy to reproduce as sitting down and reading a paper? And then a couple more checklists here. I'll just breeze through quickly so we can get to the demo. But we also looked at experiment style. So here we were thinking of how can we make reproducibility more user-friendly and cost-effective. So this is looking more at kind of how do we do reproducibility and looking more at the kind of incentives and structural aspects of that. And then there's a lot of other stuff, as I mentioned, in there. So I recommend checking it out. It's definitely got some useful nuggets and could potentially help improve artifacts for the evaluation. So I'm going to go ahead and skip through, I think, the rest of these slides. Trovy I'll be showing you momentarily. We're going to go through what Trovy is, how it can be used to share artifacts for experiments. This is just a chart showing the growth of Trovy over the last couple of years. So just to emphasize, people really do use this. If you put your artifacts on here, people are going to look at them. They may even run them. And you can see over here, we got over 230 artifacts uploaded on Trovy as of today. Trovy is, again, we'll go through this stuff, so I'm going to skip through most of this, but it's integrated with GitHub, so it's very easy to integrate it into your current workflows. And then I'm going to skip this slide. Finally, the last thing I'll mention here briefly is DayPass. This is another Trovy-related feature that's going to be useful for sharing your artifacts with reviewers. So this may not be necessary for this for your purposes. However, in the future, if you have an artifact that you perhaps, or if your SC artifact is something that you would like to, have other people continue using after, DayPass is basically a way for you to say, hey, people can use this artifact. They can use some of my resources tied to my Chameleon account to do it. And that way they have access so they can run the experiment. And I think that is the end of the slide. So I'm going to kind of jump into going over more of the actual stuff that I just talked about and was showing slides of. I don't know if it would be a good chance just to stop briefly and see if there's any high-level questions at the get-go here. I'm not sure if the participants are able to raise their hands or not, but if not, you are also welcome to add questions to the Q&A. Okay, so here we are on the ChameleonCloud.org page. So this is what we call the Chameleon portal. This is going to be kind of the main website where you're going to interact with Chameleon. First thing you're going to want to do, of course, is create a account. So I'm just going to open up a private window real quick just to show you. We support login and authentication through federated login, and this is done through Globus. So we actually have tremendous amount of support for existing organizational logins. Good chance you probably won't even need to create a new account in order to use Chameleon. You'll just be able to link it to one of your existing accounts. If you don't have an organizational login, we do also offer logins through GitHub, Google, and Orc, although we really highly recommend using the federated login if you can. Just makes things way easier down the road. So that's going to be kind of the first process. You're just going to create your user account, get signed in. Once you're signed in, the other thing that you're going to want to do is, so I'll go to our user dashboard here. You're going to need to get a project on Chameleon. So in this case, I think what we've agreed to do is for folks who are going to be using Chameleon for the supercomputing artifact evaluation, to be requesting projects and just including your basically a special code, SC 2025. And this just tells us, oh, okay, this is someone who's going to be using the platform for the evaluation. Normally, we would only approve projects that are coming from folks who are doing computer science research, which of course most of you would include most of you. However, we do tend to kind of limit it to for international PIs. So So there is a manual review process between signing up for Chameleon and then actually getting project allocation. But once you have a project allocation, you can log into Chameleon, and then you're going to want to go to your profile, request PI eligibility. So this is going to be what gives you the ability to request new projects. And then once you've had PI eligibility enabled, you'll be able to create a project. And the project is going to just be a very simple kind of description. So you'll just give a title, justification, abstract, and then you submit that. And once that gets approved, then we can actually go in and start using resources. So it's just kind of a brief kind of prereq for getting access to Chameleon. Joseph, I don't know, is it the case that all the authors are going to be requesting their own projects, or will they be using one project and just getting added to that?
I would assume that is enough. So how did you do that with the code?
I think before we did it with, we had one project.
Okay, yeah, I think that's fine.
Okay. So in that case, there'll be some special instructions that I guess we'll need to get. But so we'll assume the project access thing is already sorted out. Once that gets, but once you have, basically, once you're connected to a project, so for instance, you can see my projects here. Most of these are, internal development projects. But once you get added to a project, it will show up on your dashboard. You'll see it under your active projects. And then you'll be able to click on to these projects here. And this is where you can add members who can use resources for the project, etc. All projects have allocations for resources. So our default allocation is 20,000 SUs, which is basically converts into an hour of compute time. We apply multipliers for specialized hardware like GPUs, so that can be higher for specialized hardware, but 20,000 is usually more than enough for folks. In this case, we may up that if we need to, but again, just a slight logistical detail there. All right, so let's just go to the dashboard. So once you're added to a project, you'll have access to the resources that are available to this project. And then you'll actually be able to start using the testbed. One important thing you're going to want to use, of course, is the documentation. So documentation is linked from here. It's read the docs. This is a very rich documentation that we have. We try to cover, almost every aspect of the testbed on here. So please do make sure you check this out. But let's go to our resource catalog. Okay, so kind of following the experiment workflow we laid out before, first question you might have is, what resources does Chameleon have? So one quick way to look at the resources we have on the testbed is to go to the hardware discovery page here and check out the resource browser. As I mentioned, all of this is going to be based on site. So certain nodes are going to be available at TAC that aren't going to be available at UC and vice versa. So it's important to kind of make sure you are filtering for a particular site if you're looking at a very specific piece of hardware. So if we look at the hardware we have at TAC, for instance, I can click on the filter down here, and then I can see all the nodes that are available at TAC. This is not showing you availability in real time. So this doesn't necessarily mean that you will be able to get one of these nodes right away. It's just showing you what capacity is actually available. If you want to look at more detail about any of these, you can click on one of the hardware, and that's going to select it. And then you're going to click view, and this will bring you to a more detailed page that has a lot more of the information about each specific node, as well as some of the system information that you might want to use to reserve those nodes. And then we also do offer some other filtering capabilities on here, as well as being able to look across different sites. So that's going to be kind of the main way to look for hardware on the platform. There also is going to be some command line ways of looking at hardware, which we'll go through a little bit later. The appliance catalog, so this is going to be where you'll find images for Chameleon. So, and this is also going to be where you can find other heat appliances or other complex appliances such as that. If you're looking specifically for Chameleon supported images, you can check this box here and see those images. And then you can also just browse through, do a search to see other images that have been uploaded by other resources. So for instance, we have some MPI templates and appliances that have been uploaded from other users. Okay, so far we just talked about hardware, appliances. So these are going to be kind of two staples where you might just go and look around, see what is there. After you've maybe found some stuff that you're interested in working with, the next question is going to be like, how do you actually reserve this stuff, and how do you start working with it? So to do that, we're going to go back to this experiment tab, and we're going to go down to the sites here. So this is actually going to take us away from this chameleoncloud.org site because it's going to take us to a Horizon application, an OpenStack application that's specifically tied to ChiaTac, right? So I mentioned the sites are very important. Literally, you're going to have to click into a particular site when you decide you're ready to start working on the testbed. So I'm going to go ahead and go with ChiaTac here. And so this is going to open up this overview dashboard, and it's going to have some basic statistics just about kind of the resources that I'm currently using, which is super interesting right now. And so this is going to be kind of your command hub, command central, so to speak, for a lot of what you're doing, especially if you're going to be using the graphical interface. Quick overview of the options we have here. So as I mentioned, you're going to have to reserve resources if you're not using virtual machines. Bare metal requires an advanced reservation. If you're going to be using the GPUs with the virtual machines, those also require a reservation. CPU VMs are on demand, so you can just get those as needed. To start with the reservations, so this is going to be kind of the place to go at the very beginning. You're going to want to create a lease for your resources. So here, you can actually see a release that I created earlier for the demo. This is a lease that I made programmatically, so I didn't actually make it on this GUI interface. But you can easily come here and create leases for resources. One really important thing that you're going to want to use is the host calendar. So this is going to show you, as I mentioned, the availability is not shown in the hardware, the resource, hardware resource. So to actually see the availability of node types on the site, you're going to want to go to this host calendar. And this is going to show you all of the resource types that are available at the site that you're on. And if you select one of these, you're going to be able to see which of them are currently reserved and which of them have no reservations. So if I look at this GPU node here, I can see that so only one of them is currently reserved, and then all of the other ones are currently open. I can also look at different timelines. So if I wanted to look a little bit further out, I can adjust this to the end of the month, and so on and so forth. So that's going to be just a really helpful tool for looking at what's available. We also have a network calendar, which is the same thing except for networking resources. And then finally, if we're going to create a lease, so this is going to be where you'll go into create a lease. This is just a basic form. You're going to have basic information like a lease name, a start date, and a start time, and then how long you would like the lease to last. I should note that we have a 7-day limit on leases for bare metal hosts. You can extend those leases for another 7 days within 2 days of expiration if the node is still available. However, we do limit that as a way to encourage sharing resources. But if you just kind of create a lease without setting any of these, it's just going to default to today, right now, starting for 1 day and ending tomorrow. And then here we're going to click reserve hosts, and this is going to be where we'll be able to specify the node that we would like to reserve. So we can specify it by node type. We have access to all the OpenStack metadata in here for nodes, so you can use these other things to filter for resources as well, although the most common is just going to be node type. And then you can add filters. But once you've specified your node type here, what's going to happen is if you don't give it a exact node ID, it's going to basically go and look for an available type for the resource that you specified. And if it doesn't find the available type, it's going to come back with an error. And it's basically going to say, I couldn't create the lease because there aren't any resources available for me to do that. So that's one thing to note. If you're getting that error when you're trying to create a lease at first, make sure you go back and check the calendar, because the chances are it may be that you're trying to reserve the node when there's just no availability. So that is unfortunately an annoying feature of the testbed. We don't have this nicely integrated into this interface here. But just to be aware, if you're banging your head against the wall, make sure you check the availability, because if it's not available, your lease is not going to get created. So I'm going to go ahead and say compute Cascade Lake, because I think that's kind of going to be a node that's available. And then here we can reserve network options. So you're going to always kind of want to reserve at least a floating IP, because that's what you're going to be using to connect to your instance. Very important. If you forget a floating IP, you're not going to be able to connect to the instance with SSH. And then we can go ahead and submit that, and that will hopefully come back quickly. Okay, so the lease is going to get created, and then basically it's going to be pending for a short period of time. Oh, it's right here. And then we should see that pending turn to active. And once the lease is active, that means we are good to go. We are ready to actually start working with the resource and setting up our environment and deploying and doing all that wonderful stuff. So that's going to be critical first step, getting a lease. Now that we've seen how that works, we can go back to compute. We can go to instances. And here this is where we're going to launch an instance. So you're going to have your project name. Again, you always have to have an active project to launch an instance and to create leases. So that's always going to be an essential. And then you're going to need test. We'll just name it test. You can give a description for your instance. And then this is the important part here. So this is where you're going to select the reservation. So as I mentioned, you're not going to be able to do the instance unless you have the lease. And this is where you're going to get stuck if you don't have your lease. So you need to have the lease and you're going to need to put that in here. And then from here, you can configure the rest of your options. So, you can specify how many nodes you specifically want to deploy. We're just going to do one. And then the next step is going to be selecting your appliance or your image that you're going to use. So again, we may just, I'm probably not going to launch this right now because it's probably going to take too long and we don't have that much time, but you select your image. Once you select your image, it's going to be displayed up here, and you'll be able to modify it as needed. And then once you've configured your source, this is where you'll be able to configure network. So we always recommend at least adding the shared net because that's going to be what allows you to get out to the public internet. But then there's other options. So FabNet, this is a lower layer 3 network connectivity. So there's some options here that you can play around with. And then finally, you're going to need to either create a key pair or import a key pair to use for your SSH. And this is going to be the step where you either create a new key pair and then include it in the instance, just like you did with the appliance and the networks. And then once you have that in, you're going to click Launch Instance, and that's going to automatically start building and then trying to launch it on the node that you did. So there may be some errors that may happen in that process. There's going to be quite a lot of information that's available for you to look at on the GUI here. So for instance, this is an instance I launched today. I can look here at some of the information about it. I can see, IPs, can see flavors and things like that. And then there's also interfaces, logs. You can launch a console, an interactive console on the instance here, although that's a little buggy, so I wouldn't necessarily recommend it. So there's a lot of information here to check out once you have your instance running. And then there's some more features here that you can use, reboot, hard reboot, etc. That's going to be kind of the main thing there. There's a lot of other options here as well. So, compute is going to be where, you're launching instances, images, and your key pairs. That's going to be where you manage all this stuff. Networks is going to be kind of the same thing, except on the network side. So this is where you'll be able to see the network resources, see the router resources, see the floating IPs that you have reserved and that you're using. Not sure why my computer is so slow right now. Again, orchestration, this is going to be where a lot of the advanced templating stuff sits. So this will be, if you're using heat templates or things like that, there's going to be a lot of features here that you might be interested in. And then we do also have storage available. So we offer object storage, and then we also have a shared file system that you can use to use for storage. And then I know I'm getting a little bit long here. I do apologize. So really just kind of went through the gamut of how you launch an instance, create a lease, launch an instance on Chameleon through the GUI interface. I did mention that we have this Trovy dashboard, which is where you can upload artifacts. So this is going to be either off the main website, so you can either go to Trovy here under experiment, or you can go to this new website that we've started rolling out called trovy.chameleon.org. They're going to be the exact same. Oops, I think it just takes a while. Yeah, this one just takes way longer to load. They're going to be basically the same stuff. It's all going to have the same content. So this is going to be a good place for you to upload artifacts, as well as look for other artifacts that you might want to repurpose. So in that sense, I thought it might be fun to kind of look at a few examples of artifacts on here. The first one I wanted to look at was this bare metal experiment pattern. So just to give you a kind of a sense of how orchestration can look outside of the interface that we were just in. So this is a Trovy artifact that I've launched onto Jupyter interface. So if you're wondering how I did that, basically there's this launch button here, and I just click Chameleon launch, and it just automatically does everything for me, sets up everything. So that's where I'm looking at this right here, is this experiment notebook. And you can see that this right off the bat has a really nice kind of mix of text, right? We can put explanation here, narrative, and then we can actually put our code for our experiment. So this is a really great notebook to check out as an example. It has a lot of useful, I mentioned Python Chi being a Python library that it makes it really easy to orchestrate your experiments on Chameleon. This has just a ton of useful codes and functionality that you can tap into. I've already run a lot of this code, so just to give you a sense of how it works. So kind of like we did, we're going to kind of log in, we're going to select our site, we're going to select a project that we're going to use. The cool part, and this is actually pretty new, is we recently updated Python Chi to be able to query the hardware catalog. So as I mentioned, there are other ways to check hardware availability. This is one particular way you can do that. So here I'm looking at what nodes are available for compute Cascade Lake R, and then it's going to look it up, and then it tells me, oh, there's 12 of them that are ready to use right now. So I say, cool, I can actually go ahead and just create a lease from here and reserve that node. And I'm not going to rerun this because I already ran it, but you can see down here the output, starts the lease, that gives you a little time lapse bar, and then it tells you when your lease is active. So after we have activated the lease, we can then come back down to the server, and we can say, okay, great. Now I got my server. I want to, or I got my lease. I now want to launch my instance. So we're going to use this server utility from Python Chi, and we're going to specify the image that we want to use. And we're going to run this, and that is going to run for a long time. You can see I ran it before. It ran for almost 8 minutes. We give you a warning. Typically takes 10 minutes for bare metal, can take up to 20 minutes. So this can be a very long step. But assuming that it runs correctly, what you should see is that the status is now active. And now I actually can see meta information about my instance. And then we come down here. So now we're going to configure the networking. So I have my floating IP. I'm going to associate that IP with my instance. And then I'm going to check to make sure my instance is connecting. And it's going to come back and tell me whether the connection was successful. And then once we get to that, this is where we can now actually run the software. So we've had our connection set up. We have the instance. What we're going to do is clone this repository onto the instance that we've set up. And then we're going to run this script. Oh, well, I got an error. It's probably because I'm rerunning this without thinking about it too hard. But it's going to rerun this script. And then down here, what we can see is running this experiment. So above we were doing the setup. Here we're going to run the experiment. That's going to give us some output here. It's going to upload the results to the object store that I mentioned earlier. So creates an object store, runs the results out there, and then we can download those results and back down to this environment, and then we can actually take those results and turn them into a graph. And so we were able to run all of this, right, just from this notebook environment while still utilizing the full power of the Chameleon system. So I'm going to go ahead and stop there. I know I've been talking for an extremely long time, probably jumping around way too much, but I do apologize. I hope that gives a lot of overview, hopefully a lot of thought about, how this could, benefit artifact packaging. Of course, I'm sure there's tons of questions, so I will just shut up here and open the floor for questions. Mark or Joseph, if you have anything you want to throw in now as well, please don't be shy.
Thanks a lot for the nice explanations. I was just wondering for the recording. So we have 3 questions already answered in the FAN. F&A, should we just repeat that, or is this also recorded somewhere?
Oh, yeah, I didn't see those. All right, so one question was, are the SU charge factors published somewhere? Oh, yes. So Mark shared that, yes, we do have FAQs on the website, and those FAQs do explain the rates for different hardware. We have another question.
Yeah, maybe
Oh.
on the SUs, I just wanted to mention, like, if you find you need a lot of node hours for your experiment and are running low on SUs, you can always request a recharge. Mark can confirm, but it's very rare that we don't allow a recharge, unless we're getting suspicious of something you're doing. But if you're showing us that you're doing actual research, it shouldn't be a problem.
Yep.
Yeah, the second question was about, when you create a lease reservation, is the number of hosts the same as the number of nodes? So maybe I can mention that with the Chi@UC and Chi@TAC sites, you're reserving a bare metal node, and the instance you launch on it is a single tenant. So the number of hosts you will have after launching will be the same as the number of nodes that you're reserving. So in that hardware browser Mark showed, you'll have an instance that's provisioned on that hardware directly. It's not like a VM. We do have a virtualized site if you find you don't need a big, powerful node all to yourself. And I think the best place to find that would be in our documentation. Yeah. So under experiment there is another tab for KVM attack. And it functions a little differently than the bare metal sites, but we have documentation showing off how to use that in particular. So at the moment, you're able to launch on-demand VMs. I will say at the end of August, we're planning on rolling out a workflow where you have to use a lease. So you can currently follow that workflow. It's listed here in the documentation. So I'd recommend reading that to make sure you're up to date as we roll out that lease workflow on KVM as well.
Yeah, thank you for mentioning KVM a bit more. We have a few more questions. First one, does MPI work with virtual machines? Is there a template like that? Also, would MPI templates contain shared NFS for nodes? Mark, do you have a
So that's a
comment on
good
that?
question. I can't recall if we have a appliance for MPI, but I think I would, I'm not an MPI expert, I must say, but we would recommend you use the bare metal sites for MPI, probably just because you're going to want to ensure that there is no neighbor issue with our virtualized site. Since if you're doing performance benchmarks of any kind, you're going to want to ensure you can reproduce the environment. And that means you need the isolation from being on a bare metal instance. And I will take a quick look to see if we have an MPI template. I don't know the details of, I see one from 2018, which may be a little out of date. I don't expect that they, oh, this one actually, yeah, is fairly recent. And I see
Yeah,
it doesn't use bare metal. But so
yeah,
I
this
don't
this
think it
one is
uses
from
NFS.
2024.
Okay. So if you need performance benchmarks, this one may give you varying results since it's virtualized. And I definitely, I'm quite positive it doesn't use NFS. On KVM, we do have an alternative called persistent volumes, which you may be familiar with if you've used other cloud clusters. So, Mark, do you want to address the next question?
Yeah, so okay, so I think if we're going to be doing a project for all authors, then I think Dogon, you should just get added to a project and then have access through that project rather than needing PI eligibility. If you're asking for like future use, we do offer eligibility for international PIs who are collaborating in some sense, sometimes very loosely sense, with US researchers. So you can always explain that context a little bit in your request. However, for the artifact evaluation, I don't think that should be an issue. Okay.
So can you request up to 256 GPUs? I will say no. I don't think we have that many GPUs. Though I think you probably could get around 24 GPUs. In order, since our nodes with GPUs are in high demand, you'll have to make a reservation in advance. Some of the GPUs, I haven't checked the calendar lately, but during the semester, those can be, 6 or 8 weeks in advance booked. So if you do need a lot of GPUs, I would definitely recommend looking at the calendar, and you'll have to look ahead for sure. But our hardware calendar should allow you to filter by, there's an advanced filter for searching all nodes with GPUs. And unfortunately, we don't have 256. I'm pretty sure. I don't know the exact number, but I think it would be reasonable to have several dozen GPUs though. And we're in a new phase of Chameleon right now. So in a few months, we're planning on having, well, I guess I can't say the timeline for sure. I'm not familiar with the specifics, but we do have more hardware in this current phase that should be coming out, but I can't speak on the exact timeline. I don't anticipate it to be this summer. For the next question, I see the first is Can you create a project as a student? I think as Mark said, there will be a shared project, right, for authors, and so we'll get around that. If normally students cannot request PI status, you may have seen that on our FAQ. And then the second question, how much does the lease cost, or is it so all of the usage of Chameleon is free to you. You don't have to pay for anything. The SUs and charges that were mentioned earlier are more a auditing or tracking thing, just so that we're aware of usage and able to share resources. And then are there specialized GPU communication libraries? So I'm not familiar with these libraries. I guess my question is, are these like, do they require licenses? Is that what the question is about? So
They should be.
Mhm.
They should be free.
Okay.
to download.
You do have full root access to the hosts you launch on Chameleon. So you're able to install any software tools you need. I do know that users have done distributed training on Chameleon. I think if you look on Trovy for distributed learning, there was a course this spring where a professor at NYU was doing a class on Chameleon using distributed learning. So it sounds like that might be useful if you could look at their artifacts. But you should be able to install these as you would with any normal cloud. And at the moment, are there any nodes with Intel GPUs? We don't have Intel GPUs at the moment. I'll mention this to the hardware lead on and see if he has any more information about this, but I'll let him know of your interest in Intel GPUs. It can be difficult to support all the different hardware configurations. So I think at the moment, most of the GPUs we have are A100s. We do have some H100s on the KVM site, but only through virtualized use. And that was, that's just for, at the moment, they're virtualized only. And that's just to ensure we can share them a little better while we acquire more nodes with H100s. And then any resources for processing in-memory devices? I am, again, not familiar with this technology, unfortunately. So this, if you ask on our help desk, someone else on the team will see it, and we can have a discussion about if anyone knows of users who have done this. But it doesn't come to mind off the top of my head right now. And then another question, if you require additional libraries, then what is the best way to reconfigure an existing appliance template? So the Trovy appliance templates that like Mark was showing off earlier, these typically will have, depending on the way they were authored, will have some sort of script that sets up the environment of the node, and you can modify that script to install whatever libraries you need. Another tool that may be useful is infrastructure as code services like Ansible. Ansible is kind of a commodity tool that there may exist an existing Ansible script to install these libraries that you can adopt to your nodes. And if you search Ansible in Trovy, there should be some examples doing that. I think in order to, I guess, address the specifics, you'll have to I'll have to see more about the usage, but if you submit a question on our help desk, we can definitely point you in the right direction and look more into the specific circumstance with details. So.
Okay, thanks. I think in the interest of time, we need to conclude at some point. I just have one last question. So you mentioned Trovi as using for artifacts. Can you provide a DOI for any artifacts you put on Trovi?
Yes, you can. So let me share my screen.
So that's actually a requirement for the artifact appendices, that every artifact has a DOI for a paper. And so if that's fine, if that's working, then sounds good.
Sorry, I didn't realize I was muted. Can you see my screen here?
Looks a little bit destroyed at the moment, but anyway, it doesn't matter. So
Okay.
if it's in the documentation, I think that's completely fine.
Yes. So there were these two Trovi dashboards Mark was showing. I don't think we have this feature on the newer, faster dashboard, unfortunately, but if you go to our documentation, there is a way to upload it to Zenodo via the dashboard, and that will give you a DOI for the version of the files.
Okay, so it works via Zenodo.
Yes, so it does work.
Okay, cool. Then I would say thanks again for this nice webinar today. I really liked it, and I hope it helped for our audience here. And I think we can conclude the webinar.
Sounds great. Yeah, thank you so much. It was nice to meet all of you virtually. And please, if you have any questions, Mark Richardson just pasted some links in chat. We have a forum and a help desk, and those are great ways to communicate. We'll see your communication there if there's any questions or follow-up. So thank you.
Okay, thanks.
All right.